Session 2 in Lecture 1 Discrete Mathematics. Before we go on today's topic, let's just have a session recap. So we said that A is congruent to B module M if A has the same remainder when divided by M and B have the same remainder. So we said that A and B have the same remainder when it's divided by M, and we can find the remainder by taking the following steps. Also, A is congruent to B if A minus B is multiple of M. So M can divide A minus B. Otherwise, A is not congruent to B modulo M. Now, let's have a look on the following problem. Okay, I can tell that you can do this by yourself, and we will do this together. Okay, before we start on question B to determine whether the case is true or not, let's just recall our line number. We have the line number as zeros, positive number, and negative number. Okay. Now, all of us knows that 2 is greater than 3 and 2 is greater than minus 2. Okay? However, the relation in negative numbers is different. So, minus 2 is actually less than minus 1. So the numbers in negative parts, as much it gets bigger, the values goes smaller. Okay, so keep this in your mind while we solving the following problem. So we said that to find the remainder when A or B is divided by 4, we need to do the steps, which is minus 55 divided by 4, we got minus 13.75. Now we take the number before fraction point, multiply by M, and we got the result as minus 52. So if you notice here, minus 55 is less than minus 52. So for sure I'm not getting a remainder here because the number is greater than minus 55. So what can we do? We need to add a 1 in here. So minus 14 multiplied by 4 equals to 56, minus 56. Now, if I subtract minus 55 by minus 56, the negative will goes, so it will be positive. Minus 55 plus 56 is 1. Now I got the remainder. So here we got that 55 equals to minus 14 multiplied by 4 plus 1. Now let's check the second number. And here we got that 5 divided by 4 equals to 1 point something, right? So 5 by 4 equals to 1.25. 1 multiplied by 4 equals to 4. 5 minus 4 is 1. So here we got that 5 is equals to 1 times 4 plus 1. Same reminder, then the congruence is there, so it is true. We can also try to find whether the case is true or not by using the second condition where M can divide A minus B. So M we have 4. 4. Is 4 can divide minus 55 minus 5? So minus 55 minus 5 equals to minus 60. So if I divided minus 60 by 4, am I getting a full number or not? Yes, I am. No fraction point, no remainder, then the condition is true. Now to check the last one, 7 to power 14 equals to 7 times 7 times 7 times 7. And this is equals to 2,400 2001. So 2401 equals to 240 multiplied by 10 plus 1. Now let's check the second number, which is 1. And we said that if 1 is less than if the number is less than m, then it is the same reminder. So when we got 1 is equal to 0 times 10 plus 1. Same reminder, then yes, the case here is true. Let's try the second condition. So as 10 can divide a, which is 2401 minus 1b, and yes, 10 can divide 2400. So right, we applied. The case is true. All right. We will be discussing about modular classes, modular explanation, addition, and multiplication of congruence classes. So here, Zm is referred as the modular class of M, where M is a positive integer. Before we just introduce the idea of modular class, let's just know this exciting fact. Every mod has a number of values as a reminder. So mod 2 give me the possible reminder is 0 or 1. So if I divided any number by 2, I might get only a reminder 0 or 1. Same, the possible reminder for mod 3 is either 0 or 1 or 2, and for mod 4 either 0 or 1 or 2 or 3. So from here I can see that you noticed that the values of reminders that can be get for any mod is equal to from 0 until m minus 1, and the number of elements inside the set equals to m itself. So here we have 2 possible reminders, 3 possible reminders, and here we have 4 possible reminders. Now, in order to understand more what is the idea behind modular class, now let's suppose I have this number line, and we will take 1 by 1 divided by 2. So 0 divided by 2 will get me a reminder as 0, because 0 equals to 2 times 0 plus 0. Okay, let's check 1. 1 divided by 2 will get a reminder as 1, because 1 equals to 2 times 0 plus 1. Now let's see here. 2 divided by 2, I'm getting the reminder as 0, because 2 is equals to 2 times 1 plus 0. 3, I'm getting a reminder as 1, because 3 is equals to 2 times 1 plus 1. And if I continue, I will get the same reminder. And whatever in here is the same for the negative numbers. So here will be 1, 0, 1, 0, 1, and so on. Okay, now if I'm looking for a congruence between 3 and 5 mod 2. Now from the number line, I can say that if I divided 3 by 2, I'm getting a reminder as 1. And if I divided 5 by 2, I'm getting a reminder as 1. Okay, now again, minus 1 is congruence to minus 5. And if minus 1 is congruent to 5, then again minus 1 is congruent to 3. So the idea of modular class is I can combine all the numbers when it divides by 2 and give me the same reminder. So for 0, I have 0, 2, 4, 6, and so on. And here we have -2, -4. Okay, and for the remainder, when remainder is 1, I'm getting that 1 is congruence to 3, congruence to 5, congruence to 7, and so on. And from here we have -3, -1, -3, and so on. Okay, here is the idea of modular class. So the modular class for m equals 6. The possible remainder I can get from 6 is starting from 0 until 6 minus 1 is 5. So the remainder, the possible remainder I can get is either 0, 1, 2, 3, or 4, or 5. And we can write it as the modular class 6 equals to 0, 1, 2, 3, 4, 5. Now each elements that any numbers 0, 1, positive or negative multiplied by 6 will get me a remainder 0. Otherwise each time will be adding 1. So we can write it as here. Now 0, 1, 2, 3, 4, 5 represents the remainder, and the first set have all the multiple of 6, which means if I divide the number by 6, I'm getting a remainder as 0. So here we replace z with 0 with negative, so 1, 2, 3, and we represent z with 0 and positive numbers. Okay, so starting from 0, then 1 times 6 is 6, 2 times 6 is 12, and so on. And here we have -1 times 6 is -6, and -2 times 6 is -12, and so on. So here we have all the numbers. When divided by 6, I get a 0 as a remainder. Now let's check 1 as a remainder. It is the same what I have in 0. I just need to add 1. So here we have 1, 7, 13, and here we have -5, -11, and so on. For 2, just you need to add 1. So here we have 2, then 8, 14, and here we have -4, -10. Sorry, I got down a little bit. Okay, same will be for 3, 4, 5, and I get each one by itself. For example, let's find the elements of 5. 6 times 0 is 0 plus 5, so we start from 5. 6 times 1 is 6 plus 5, 11. 6 times 2 is 12 plus 5, 17. And from here, we got that 6 times -1 is 6 plus 5 is -1. And then 6 times -2 is -12 plus 5. We can get -12 plus 5 equals to -7. And so on. So moving from one set to other, you just need to add 1, and moving from one element to other in the same set, you just add 6. Okay? Now, by your own, you can stop the video and try to find the modular class M. So here, the remainder. And to find the set, the elements of modular class 3, 0. Class 0, you should just multiply 3 by z. and 3 by z plus 1 to find the elements of class 1, and 3 by z plus 2 to find the elements of class 2. Okay, let's identify the second topic of our session, and by the way, it is an application of modular class. So here we have modular explanation, and modular explanation means when I have a number with a power mod m, how we can find the results. So here we find that we need to find the remainder when 9 to power 342 is divided by 10. How to do so? We just need to simplify the number and find the remainder for the simple number to 10. Okay. First of all, we will start with 9 to power 1 mod 10. Now 9 mod 10, as we said earlier, if the number is less than 10, then it will be equaling the same number. And by the way, I'm looking for the smallest remainder I can get, which is 0, 1, or 2. Okay, now we will go for next, which is 9 to power 2. Now 9 square mod 10 is equals to 9 times 9 mod 10 equals to 81 mod 10. And when I divide 81 by 10, I'm getting a remainder as 1. You can either use the previous steps to find the remainder, or we can make it simpler that 10 is only multiple. So I can get the whatever here in the units place, it will be the remainder. Okay, and you will see this in our next questions. So I'm getting 9 to power 2 to be simplified of 9 to power 342. How to do so? We all knew that xa all power b equals to xa times b. So what I can do here, I need to convert the huge number to a smaller number. So I need to change 9 to power 342 to 9 square. And how I will do this? I need just to apply the rule in here. So 9 to power 342 is equal to 9 square to power, if we divide the number by 2, which is 342 divided by 2, I'm getting as 171. So I replace this by this in our question in here. So 9 to power 342 mod 10 is congruent to 9 squared to power 171 mod 10, and this is equals to 1 to power 171 mod 10. Now 1 to power 171, continue on here, is congruent to 1 mod 10. So we got that 9 to power 342 is congruent to 1 mod 10. So the remainder equals to is 1. Okay, let's check the next problem, and I believe that it will be more clearer to you. So here we have 6 to power 248 when it's divided by 7. What we need to do, simplify the huge number here to number smaller, find the remainder, replace it. Okay, so 6 mod 7 equals to 6 because 6 is less than 7, so it is the remainder itself. Okay, how about 6 square? 6 square mod 7 equals to 36, and 36 mod 7 is, if I divided 36 by 7, I'm getting 35. Then yeah, the remainder is 1. Either we do these simple steps that we learned earlier, or you can do it in your mind. So the nearest number of 36 from multiples of 5 is 35. Then 37, yeah, and then we got the remainder as 1. So let's just convert 6 to power 248 to something look like 6 square. So we can see that 6 square all to power 124. Now we can find the remainder. So 6 to power 48 mod 7 is congruence to 6 square to power 124 mod 7, and this is equals to 1 to power 124 mod 7, and yes, 6 to 48 is congruence to 1 mod 7, and so the remainder equals to is 1. Again, one more example with an arithmetic operation in here. Okay, so we have, first of all, we need to find the remainder when 7 to power 348 when divided by 8. And then we need to find the remainder when 25 to power 605 when divided by 8. Okay, then we just add them together. So here we have 7 mod 8 equals to 7 because 7 is less than 8. 7 square mod 8 equals to 49 mod 8, and we got that 49 mod 8 equals to 1. So we can stop in here, convert 708 to a 7 square. So we just divide 348 by 2, and we got that it's equal 174. So here we have 348 power 2 mod 8 is congruent to 7 square to power 174 mod 8, and this is 1 mod 8. So we got here the remainder as 1. Now let's check the second number, and we got 25 mod 8. If I divided 25 by 8, I'm getting the remainder as 1. So no need to change anything here. We knew that 25 to power 605 mod 8 is congruent to 1 to power 605 mod 8, So here we have the remainder as 1. Okay, now we knew that 700 to power 8 348 plus 25 to power 605 mod 8 is congruent to 1 square to power 174 plus 1 to power 605 mod 8, and this is equals to 2 mod 8. So the remainder is 2. Here we have a small note that we can add, subtract, multiply on both sides of congruence and the relation won't change. But we can only divide in both sides of congruence with no change in the relation by a number C if the greatest common divisor is 1. So in order we divide on both sides of congruence by a number, it should have the greatest common divisor with m is 1. So let's see the example in here. Here we have 44 congruence to 24 mod 5. I can simplify here by dividing by a number, but I need to make sure that the number has a greatest common divisor with 5 is 1. So I can divide both sides by 4 because GCD 4 and 5, the greatest common divisor between 4 and 5 is 1, and this number is also a common divisor between A and B. So 44 divided by 4 gives us 1, and 24 divided 24 divided by 4 gives us 6 mod 5. So again, the relation here is not change because whenever I divide those number by m, I'm getting the same remainder. Okay, now let's see the second application of congruence classes, which is addition and multiplication of congruous class. Let m be a positive integer. The congruous classes of modular m, we said that m starts from 0 till m minus 1. Now I can add 2 sets. I'm getting the possible remainder of adding 2 sets, and I can multiply them. What do we mean by this? In case we have 3 plus 2, I'm getting the remainder 5. Okay? 3 times 2 gets 6, but 6 is not a class on modular class 6, then I can represent it by 0. So what is basically we can do here, we start from 0 until m minus 1, which is 5, then again continuing adding the numbers here. So here we got 6, 7, 8, 9, 10, 11, and then we got 12, 13, 14, 15, 16, and 17, and so on. So here we got that 9 can be represented by 3. 20 can be represented by 2. So if I add 2 plus 9, it will equal 29, and this equals to 5. It's also the same. 3 plus 2 is equal to 5, equal to 20 plus 9. And this gives us that 29 is congruent to 5 mod 6. So if I divided 29 by 6, I will get a remainder as 5, and 5 divided by 6 getting the remainder as 5. And here we can introduce the chaos table. Chaos table represents that adding each numbers of the sets will give us another same class in the modular class 6. So let's take this example. 3 plus 3 is 6, and 6 can be represented as 0. Here we have 4 plus 5 is 9, and 9 can be represented as 3. Here we have 5 plus 3 is 8, and 8 can be represented as 2. How we can also find this? I need to find the remainder when I add those two numbers. For example, 5 plus 5 is 10. Now 10 mod 6 equals to 4. So 10 represent by set 4. Let's suppose, see here we have 5, 5, 10, 10 represent by 4. In case we have 5 plus 2 equals to 7. 7 mod 6 is 1. So here 5 plus 2 is 7, and 7 can be represented by 1. Again, the same for chaos table for multiplication. So 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, and so on. Let's take a big number here. In case we said that 4 times 3 is 12. 12 mod 6 is 0. So in case we have here 4 times 3, I'm getting the remainder 0. Here we have 5 times 5 is 25. 25 mod 6 equals 1. So here 5 times 5 gives us 1. And the same for the rest. Okay, now let's find the remainder when 107 plus 23 plus 109 plus 35 plus 93 is divided by 5. Before we introduce the chaos table, what we can do, we just need to add all these numbers and divide it by 5 and get the remainder. So 107 plus 23 plus 109 plus 35 plus 93 will give us 367 mod 5, and we got the remainder as 2. Let's get the benefit of modular class. And I knew that 107 divided by 5 will give me a remainder as 2. How I know this? I need to check the nearest number of multiple of 5 to 107. So I know that 105 is the nearest number to 107. Now 107 minus 5, 105 is 2. 23, the nearest number is 20, so the remainder is 3. 109, the nearest number is 105, so the remainder is 4. 35, the nearest number is 35, so the remainder is 0. Then we have 93, the nearest number is 90, so we got here the remainder is 0. So all of these mod 5. Okay, this is congruence 5 plus 4 plus 6 plus 4 is 10 plus 2 is 12. So 12 mod 5 is congruence 2. The nearest number of multiple 5 to 12 is 10. So here we have the remainder as 2 mod 5. All right. Let's check another example here. What is the remainder when 16 times 5 to the power 32 plus 9 is divided by 6? We will take one by one. So 16 mod 6 is excellent 4. Because The nearest number to 16 in multiples of 6 is 12. Now we can do the equations in our head faster. Then we goes to 5 to power 32. Starting from 5 mod 6 is 5. Then we have 5 square mod 6 is 25 mod 6, and we got the result as 1, because the nearest number in multiple of 6 to 25 is 25. Okay, so we need to convert 5 to power 32 to 5 square, and we got that 5 is equals to 5 square all to power, that just divide 32 by 2, we got as 16 mod 6, and this is congruence to 1 square, 1 mod 6. So we got that this is equals to 1. Now here we have 89 mod 6 is equal to 14, 84, we got as 5. Okay, now here we need just to replace each number by its remainder. So we got that 16 multiply 5, 23 plus 89 mod 6. This is congruence to 6. When 6 divided by 6, I got the remainder as 4. Multiply by, when 5 to power 32 is divided by 6 is 1, plus here we have 5 mod 6, and this is congruence to 4 times 1 is 4 plus 5 is 9 mod 6, and we got the remainder as 3. So remainder is 3. Here we have another shape of the problems. We got the explanation point, and we know that 1 factorial is 1, 2 factorial is 1 times 2, which is equals to 4. Then 3 factorial is 1 times 2 times 3 equals to 6. Then we have 4 factorial equals to 1 times 2 times 3 times 4 is 24. Then we have 5 factorial equals to 1 times 2 times 3 times 4 times 5, which is the equals, just a moment, equals to 120. 6 factorial is 1 times 2 times 3, 4, 5 times 6, and this is equals to 720. 7 factorial equals to 1 times 2 times 3 times 4, 5, 6, and 7, which equals to 720 times 7 is 5040. Now we need to find till 100 factorial. we need to find the reminders, then we divided by then we find the whole when divided by 18. So 1 mod 18 is 1, 4 mod 18 is 4 because the number is less than n. Then 6 mod 18 is again 6. Then we have here 24 mod 18 is 6. And here we have,
I couldn't quite hear you.
sorry.
Could you please repeat what you said?
Okay, 120 mod 18 is 12. Then 720 mod 18 is 0. And 5040 mod 18 is also 0. So if we continue until 100 factorial, I will keep getting a reminder as 0. What I have to do here, I need just to add whatever reminders I got in here. So the following equations equals to 1 plus 4 plus 6 plus 6 plus 12 and should be plus zeros mod 18, and this is equals to, we got this addition as 27 mod 18, and we got that when the following factorials divided by 18, we will get a reminder as 9 mod 18. So the reminder is 9. And here we reach the end of session 2, where we discussed about modular class, modular explanation, addition and multiplication of congruence classes. We'll see you inshallah in next session.